Hello, everyone. Thanks for hanging until this late and choosing to attend this talk. There have been quite a fun talk so far, and I hope this one is also going to be an amazing one. Today, I'm going to talk about ASEF, the story of it. ASEF, as I call it, Android Security Evaluation Framework. And we're going to cover like a lot of aspects of this framework and how the idea came into existence and what it has to offer to the Android security. Before I do that, I'll briefly give you my introduction. I don't mean to flatter myself too much, but I'll cut it really short. I work as a vulnerability signature QA engineer at Qualys, and actually over there I get to enjoy my childhood hobby of breaking things as a profession. But along with all the fun that I'm having, I also get to learn how to build things, how to automate things. And when I get to build those automation tools, I get like extra time to explore new things. And that's how I actually started exploring Android security over the last 1 year. And combined with all those factors, here is today's talk. So let's find out what we're going to cover today. Initially, I'll give you like a brief overview about the manual research that I conducted, all the tactics that I used. And I'll also talk about the limitations of such tactics and what automation can make a difference and what ASEF has to offer to it. So we're going to cover the detailed design of ASEF. We're going to do the demo. We're going to cover all the stats that I have collected. It's going to be pretty interesting. And once we are done explaining ASEF, we'll see what type of real-life problems we can solve. And if we can do that, then we'll see what we conclude today. So let's find out. So I'll just start with a very brief overview about my personal experience as a security engineer working on the Android OS platform. As we all know, Android is an open source operating system for the smartphone. So that opens up a huge market for all the smartphone manufacturers to add their own flavors to it and create their own interpretation. So we see like there are a lot of interpretation already out there in the market, which is actually a key strength of it being so prominent in the market. However, from the security engineer's point of view, the way I see it is there are times when you have to be like very careful about your requirements have to be very precise, and you have to be very careful when you're trying to address any issue out of like the cluster of Androids out there. At the same time, there are times when you want to make a very generic statement. You wanna consider all the possible iterations out there in the market. So that makes it a little bit hard as a security engineer. However, we're gonna talk about the element that makes this platform very smart, which is the apps. And we're gonna perform the security evaluation of these Android apps. One of the places you can get this app is from the market. As you can see that initial version of these markets were a little bit relaxed. So along with some genuine app from the developer, there were malicious apps were also injected into the market. And again, user has to worry about like whether the app is genuine or malicious. And in order to solve this problem later on, we saw that some of the markets like Google Play came up with their own security service called Bouncer in order to protect their markets from being injected by an attacker via a malicious app. However, there are enough evidences out there that shows that even these security services are not entirely bulletproof. There are attackers who have still managed to bypass this and put the malicious app on the market. So again, the question for the user is, what do they have to make that decision whether to install an application or not? And again, this is only a part of the picture where we are talking about the users who are religiously sticking to the downloading an application from the market. But talk about most of the users who are very more adventurous. For them, this is only a part of a problem because they want to root their device. They want to install applications from different part of the internet. And if you consider the world inside these markets a bit more regulated, the world outside it is quite lawless. So what's the gist of the story? I mean, if you are a user, what is in your hand in order to make that judgment call, in order to make that final decision whether to install an app or not, whether it's a genuine app or a malicious app? Well, Google's answer to this is permissions. Well, we all agree, yeah. Permissions are out there in order for us to make that decision. But the real question is how convenient are those? I mean, sometimes it feels like reading a software agreement, and which is very inconvenient, and most of the users are inclined to ignore it. At the same time, there are times when the application is very appealing, or maybe I'm very tempted to try it out. I might just ignore it in that case. So that's somewhere the starting point of my manual research started, where I try to categorize all these applications based on the permissions. And what I realize is just relying purely based on the permission, or in general, the asset information that are associated with this Android application isn't completely conclusive or neither comprehensive. So I dig a little bit further on the manual research, where rather than focusing on the functionality aspect of this application, I wanted to focus more on the behavioral aspect of it. In a sense that I don't just want to focus on what this app is telling me that it is going to do, like it's a game app or a social networking app or a utility app, but I'm more interested in about the way it behaves when you install it or use it. For example, what type of server does it talk to? What type of network activity does it conduct? How much data does it consume? Does it have any security flaws? Is it talking to any server which is already blacklisted by Google? There are kind of questions around this behavioral analysis that I was interested in. So I just started thinking of creating an environment for this behavioral analysis of an app. So I can start with n number of tools in order to build this environment to perform such type of behavioral analysis. But I thought of starting with the most basic utilities available out there. And once we build like a solid platform, we can always go ahead and integrate more utilities and build upon it. So one of the things I was doing was just download an application from an internet, install it on a virtual device, and just fuzz with it, just trigger certain behaviors. While you're doing all this, just collect the network traffic. At the same time, you also collect all the activity logs on the virtual device and try to make sense out of this data, like what is happening behind the scene. So Android SDK will provide you like emulator utility from which you can create the virtual device. You can also get the Android debug bridge, which will allow you to talk to this virtual device. Also, there is an Android asset packaging tool which will let you construct all these commands. It will help you in constructing all these commands in order to talk to the virtual device. Again, Wireshark is a widely available packet capturing tool that you can use. In order to reconstruct the source code, you can start with the dex to jar, convert the Dalvik executable file from the APK file and get it to the jar file. And once you get into the jar file, you have a lot of options in order to decompile the source code. And then you can actually manually dig into the source code. And you can use any IDE in order to look at this source code. So these are like very basic fundamental utilities that I started with. And I started doing this manual research for like large number of applications. Like I download the application, I do all this behavioral analysis, I collect the data, I go manually, I try to make sense out of it, I try to interpret it. And it seems like it's too overwhelming. I mean, imagine like it takes like hours and hours of work to do such thing for one application, and the rate at which the new applications are coming up in the market, it's just too hard to keep up at this rate doing the manual research. So I was looking for more solid answer to it, and one of the answers that I came up with is automation in form of ASEF. So in the next few slides, I'm gonna talk about the design aspect of ASEF, and we're gonna start with the top level overview to the very fine design aspects of it. So before we even go into further detail, we just look into like, if I give you an ASEF right now, this framework, what you can possibly do with it. Imagine there are 3 different type of use cases that I consider while designing this framework. First one is if user has just downloaded an application from an internet and they want to know all the questions that we just asked. All they have to do is just point that APK file to the framework, and it will give you all the results after performing all the behavioral analysis tactics that we talked about thoroughly automatically. But again, there might be some researchers who might have like tons of applications they want to go through, not just one application they might be interested in. So in that case, you can run this framework against the n number of applications. It will perform the same task one by one on each application, and it will give you the results once it's all done. But here we are only considering the cases where you actually have the APK file, the actual source file of the application on which you can point it to the ASEF. But most of the user might not have the APK file. They might have just installed the application from the market. And in that case, all they have is install applications on their devices. So if they want to scan their device, all they have to do is just connect their device with the framework, with the machine running framework, and it will give you all the results. And they don't have to worry about anything else. Well, while I'm saying that, I just do want to make sure that at no point ASEF will run any passive or active test on the device itself. And how we are achieving that, we're going to go into much detail of the design. So there are 3 different phases ASEF is working. Its design flow works in like 3 different phases. First phase is a passive, where it tries to collect all the data which is required to run all the tests. In the active phase, it will actively run all the tests on the virtual device. And then once all the data is collected, after running all the test cycles, it will try to interpret this data in order to conclude some results. So let's look at every phase one by one. Irrespective of your input, the configurator module will start. This is the initialization mode. ASEF is trying to initialize, and these are the modules that will be called one after one. Again, this is an automation framework, so we don't want to have a user bit overwhelmed by entering like long nested arguments every single time. So there is a configurator file. Once you configure with all the default parameters, then the framework is good to go for n number of tests that you want to run. At the same time, it will also help you in like creating the virtual device, which will be also helpful in migrating this framework from one machine to another machine. We will also do the session cleanup before we start our test cycles. So ADB refresh module will take care of that. There might be time where many devices might be connected to the machine which is running ASEF. So device detect will let you know that, hey, I have successfully detected either this virtual device or this physical phone, and this is the device ID of it. But make sure when you connect your device to the machine running ASEF, enable the USB debugging mode in order to talk to the device. So once the ASEF is initialized, it goes into the normalization mode, where we talked initially that the first 2 categories of the use cases are same, where you actually have the APK file on the machine, and you can just easily point it to the framework. But imagine when you have a device on which all these apps are installed, the extractor module does its magic, where it will extract all these applications one by one on the local machine. And once we get these applications, it will create a list of array where all these APK files are stored. And how it does it, the extractor module queries this device for the list of installed packages. And once it finds the installed packages, it will iterate and try to find at which location these applications are stored. And while it's doing this iteration, it will also try to find out whether these apps are system apps or the user install apps. As such, our focus here in this framework is to test the user install application. We're gonna filter out the user install application and only extract those ones at the local machine. And once we get to that point, we have a list of array where all these APK files are stored on the local machine. And again, the importance of this mode is also because irrespective of what type of input you have, if somehow you get to manage to get to this point, the rest of the functionality of the framework will be almost same. And once the normalization mode has run, we can just jump into the test cycle, but we want to take a little bit more careful approach, and what we're going to do is we're going to create a set of, we're going to create a hash table in which for each and every application, we're going to extract all the asset information like package name, version number, when the application will be started and stopped in the test cycle. That will help us organize all our results later on as well, and help us triggering all these commands while running the test cycle. And in order to organize our data, which we're going to collect in the test cycle, we're going to create a test result archive. So the framework will create the directories based on the timestamps, and within those directories, different directories will be created based on the name of the application, and within those directories there will be log files in which we'll be capturing all the data. So once we have all this hierarchy created, we are good to go for the active mode, in which what we're going to do is first we're going to see whether the virtual device is running or not. So if it's not already running, we're gonna boot the virtual device. We're gonna actively check whether the device has been booted or not. And all these default virtual devices, they boot with the display being locked. And in order for user to see what's happening on the virtual device, we're gonna unlock the device remotely. But if the virtual device is already running, there is no need to go through this entire boot process, and we can just bypass it and then just go ahead with our test cycle. So virtual device launcher will take care of these two possibilities. But there might be some security researchers might question that, hey, the default virtual device has its own limitations, and there are a few things, or maybe there might be some application might be smart enough to detect that, hey, this is a default settings on the virtual device, and they might not behave maliciously, and we might not able to cover those applications in our coverage. So in order to answer that question, I have added one more option where you can just bypass this entire virtual device phase, and you can just point this framework to run all the tests on the actual physical device, where all these tests will be performed on the another physical device that you have connected, and you will get the more real life-like data. Again, now we are all set for running a test cycle. We'll capture the timestamp. We'll start two background processes, one to collect the log on the device, and another one to collect the network traffic. And once we are done that, we're gonna go into the installation mode, where we're gonna point the application to the right device where we want to install it. Once we have successfully installed it, we're gonna automatically launch it, and then it will try to send different gestures in order to trigger those behavior that we are interested in and collect the data. And once it's all done, it will uninstall it, and it will capture the stop timestamps, and it will close all the processes that we started for that particular application. And again, this cycle will be iterated for n number of applications that you have provided. Till now, it looks fine. However, there is more to it, which I call it an extensive mode, where if the researcher is not only interested in the behavioral analysis aspect, but to find out more behavioral patterns, they can also go ahead and collect the kernel log, memory dump, and running services at the different stages of this test cycle. And that way you can actually cover, that way you can in fact do some forensic analysis and find out some behavioral patterns out of this collected data. However, there is more to this. It seems like a recipe that has all the ingredients, but there is one element missing, which I call it marination time, which allows you to fine-tune this test cycle in such a way that you can decide how long you want an application to spend inside the test cycle. You can tune this time in such a way that the app can spend like, you can construct a 3-minute or 5-minute or maybe 30-minute test cycle for each and every application, so as to increase your coverage of the test. Once all the data is collected, the interpret phase will try to parse this data, analyze it, and generate some results. So we talked about capturing the network activity. So this parser will try to parse all the URLs and IP. It will run it through the Safe Browsing API of Google, and it will tell you like what Google Safe Browsing API has to talk about all those servers. I mean, if your information is being sent to some server which is already blacklisted, then you will come to know right here. At the same time, we will also look into the access rate of these servers, and we'll try to find out what are the type of servers which are actually serving the ads, and if the access rate is too high, then are those really an aggressive adware for you? And we'll look into it more in detail when we look into the results. The traffic analyzer will try to find out the amount of bandwidth that an app has consumed in that test cycle, and it will tell you all the data usage and bandwidth results for that particular test cycle. If you are worried about your data being consumed, then you might be interested in this type of statistics as well. The vulnerability detector is something that not part of the behavioral analysis, but it's something that I went through all these security advisories for Android and found the most high priority, high severity vulnerabilities and created signatures. And then what we are doing here is we are running all these packages that we have extracted, finding the versions and running it through the vulnerable versions that are already known. And we are displaying the user that, hey, you have currently installed these many applications, out of which these applications are vulnerable to some known security flaws. And you might want to take some action to it. Again, we talked about permissions a little bit and mentioned how the permissions have limited scope in order to make the decision. But again, we don't want to completely ignore it. What the technique that I have created is where rather than going through every single application and iterating every single permission, just create a unique set of permissions out of all those applications and see which permissions are being used by which application. How this mapping makes sense, we'll see in the charts when we talk about the results. And again, you can also decompile all these APK files if you want to do like further manual research, and you can get to the source code. And again, the same tactic can be used to the API mapping as well. Blacklisting is something that is more like a community thing. If we don't have once the app gets blacklisted, then it just disappears from the market. So we want to make a list of all these packages which were of the application which were like blacklisted. So that can help us learn more about them. At the same time, if the app is already blacklisted, then we can just let user know right away. Seems like we talked a lot about this framework. So let's just look at the demo and see how it works. There are many ways I can give the demo, but I'll pick the most obvious one, which a user might try, like after they download the framework, what they might be most interested in just scanning their device. So I have an Android device with me. All I have to do is just connect it with the machine that is running the ASEF, and I'll walk you through the demo. So once I'm pick the device scan mode and just going to give the option -D, and the framework is going to start. And as you can see, all the design slides that we talked about, it will start with the configurator mode. It will detect the device. It shows you the ID of the device. The extractor is running now. It has extracted all these applications. It is telling the converter module is telling you all the asset information associated with these applications. The test result hierarchy module is creating all these test directories for the current timestamp and organizing all the data. Now we are going into the device launcher module, where it hasn't detected any virtual device already launched. So as you can see here, the device got booted. And as we mentioned in the design slides, that we don't want to time it, the boot time of this virtual device. So we are actually actively tracking the boot process. And once we get the signal whether the device has been booted properly, we're going to move ahead with our test cycle. So as you can see, the device has come online, and now it's waiting for it to complete the boot process. And I mentioned that all the default virtual device, they start with the lock mode. So in a while, we're gonna send the remote swipe and unlock the device. So it has unlocked the device, and now one by one, it will start installing application and run all the tests. And we already started the TCP dump and the ADB log capture in order to collect all the behavioral data. So it has successfully installed the first application, and you can see it will be launched. And now we are sending all the different gestures. I'm trying to keep this demo quick and short, but when you run this framework, it will be very extensive. It will send a lot of gestures, and you can collect a lot more data. But we are going to just run it through two applications, but it can perform this task for n number of applications. Now it's going to install the second application, and once it finds it's successful, then it will go and start sending the different gestures to it. So now it's going to launch the second application, where we're going to fuzz with it, and we're going to collect some data. And behind the scene, we are also collecting all this packet capturing and the ADB log on the virtual device. And we're going to go into the interpret mode, where we're going to trying to analyze this data. So now it's done testing these two applications. It is going to see, as you can see, like what type of URLs it has accessed. Here you can see that this application is trying to send some user statistics to a website, or like these are the type of servers it has talked to. This is the number of bytes that it has exchanged during this test cycle. And at the same time, I talked about the vulnerability detection, where this app was found to be vulnerable to this version. And this is the CVID that it is telling you, and user can refer to it and decide whether to update the application or what to do with the version of the application. So these are the list of behavioral data that we come to know once we run the application. Again, there are a lot more features to it. You can run it extensively, but this is a brief demo which shows the functionality of this framework. But I want to share a lot more about like the type of data that I have collected while running my own tests using framework. So let's move this to the side. So now you got an idea about how ASEF works. We're going to look into all the statistics that I have collected over the period of time for different applications. The one that I was most interested in if the applications are leaking any of my personal private or sensitive information. So I took a bunch of applications, like 80 or so, and I found out that out of them, after running a test through ASEF, 6 of them were leaking private data. And we'll go through them one after one. Like here you can see that this application is sending your IMI, which is a device ID number, and your phone number to some server somewhere. Again, this is the default device ID of an emulator and the default phone number. These are all the default settings of the emulator. Imagine if you have downloaded this application on your device, these numbers would have been yours. So using ASEF, I came to know that, hey, whether should I install this application, knowing that this is actually leaking my personal information. At the same time, there was one application which was actually sending the serial number of the device to some server. The subscriber ID number, which is an IMSI number, was also being leaked. I was also interested in like knowing how much bandwidth does an application consume. So I fine-tuned the test cycle to be 3 minutes, and I collected all the data for the number of bytes it exchanged during that test cycle, and I found out some of the applications were like creating very high network traffic, whereas some of the applications were not. So again, if I'm more interested in finding out more about the network activity and such, I might start focusing as a researcher on this side of the graph and pick and choose my applications if I have to deal with like hundreds and thousands of applications. But again, the data uses was only like limited information. I was more interested in finding the aggressive adware. In order to do that, I first had to find out the access rate at which these servers were talked to. So this graph shows you that number of servers were accessed for each and every application. And more interestingly, at which rate these servers were talked to. So in this graph, you can see that there were different servers that were communicated, and the height of the width shows that the number of servers, and the height shows that the rate at which they were communicated. And you can just set your own threshold saying that, hey, if the server is talking to, if the app is talking to some server which is known to be an ad server, and if it's like more than twice a second, then you might call it as an aggressive adware. And here is one of the examples where an application was trying to send a request at very high rate, and maybe for me it might be an aggressive adware. Again, the definition of the aggressive adware is a bit more broader. We are trying to look at it from the access rate of the rate at which the ads are pushed onto your device. I talked about the permission mapping while going over the design slides, where I was more interested in looking into what type of permissions are being used by the different category of apps. So I took like 1,000 applications and I created the permission distribution in a sense that rather than going through every single application and find out which permissions, I just created a set of unique permissions out of them and find out which permissions were most widely being used. So the these 1,000 game apps were like using 25% of them were using like internet permission. That means that in order for that application was asking you to have an internet access in order to be installed. Again, but there are certain permissions that I was actually very surprised to find, in a sense that some of the applications were even asking for like send SMS, write SMS, even write context, or mount unmount file systems, which you might have a hard time imagining. Why would a game app will ask you to do so? So again, this is still not yet conclusive, in a sense that this gives you enough lead. In a sense, if I'm interested in SMS Trojans and such, I might start looking into these applications. So it gives me enough leads about how to approach and how to reverse engineer the applications. Again, vulnerability scanning, as I mentioned, I had like 75 applications installed on my device, and I was interested in finding out how many number of vulnerabilities are there in my application. So I just took my phone and I ran a scan with ASEF, and I was a little bit surprised that I found like 12 applications which were vulnerable for like severity 10, and that was quite surprising. But more surprising was some of them where I was like were very highly used applications like Adobe Flash Player or Mozilla Firefox. So then at that time I realized that, hey, I need to go ahead and update my applications and get them all to the most recent version available from the market. Maybe I haven't updated them, that's why I'm vulnerable. So I did that, and I updated all my 75 applications to the most recent version from the Google market, and I felt a little bit safe. Well, but not too long, because the next data that I found was not surprising, but a little bit shocking, in a sense that 6 of the applications, even after updating all the applications from the Google market, were still vulnerable to some known security flaws. And here is one of the examples where one application, here is the most recent version, and this is the known security flaw. And I guess developer hasn't taken much action in order to update or patch it. So I see like there are hundreds and thousands of people who also download this application are currently vulnerable for these security flaws, which can be exploited. So far we talked about the design and the statistics parts of it, but imagine having this framework as an open source. We also want to talk about the extending the framework part of it. How possibly you can take this framework to the next level. So currently we are collecting the packet capture through TCP dump and activity log through ADB log. But imagine The design is so simple. You can add as many command line tools as possible in order to increase the functionality of this. So there are a lot of functionality that can be added at this layer around the test cycle. But there is another place where we can also improve upon is the virtual device itself. We want to increase the functionality of the virtual device or the physical device where it has an ability to detect certain malicious activities, which some smart malicious apps might be very smart enough to like overcome those type of platforms. So we wanna make the contribution in the platform as well. So if we have those type of images on which we can do those type of analysis, we can use that in order to expand the functionality of the framework. So I think we have the framework. Now let's just try to solve some real life problems. One of the idea that I had was like, if I make this framework an open source framework, there might be so many developers who might be interested in creating their own app stores. And in order to protect and promote this type of app stores where people haven't yet gained enough trust, this framework can be easily integrated where it can give you the results of all this behavioral analysis that it has performed for all the applications that are there on the market. And user can get to see before they download the application and say that, hey, these are the activities that they are doing, these are the type of analysis that ASEF has provided, and whether to install an application or not. So that makes life a little bit more easier for the emerging markets and the users which are a bit more adventurous and trying different markets. However, there is another place where I think it's a bit more challenging to solve problem is for the applications which are already installed on the device. So in that case, imagine like if you have a large company where there are hundreds of Android users, and you wanna test all these applications regularly. One simple solution you can come up with is give this framework to the IT guys, let them deploy this on a server, and let them manage all these Android devices one by one, and let them scan and collect the data and such. But it's not only it doesn't only sound unfair, but it sounds very inconvenient. Not only for the IT guys, but also for the users, where they have to like even leave their phone for like few minutes in order to perform this test. And who would want to do that? I mean, they have their whole life in these phones, like email and contacts and calendars and everything. So that doesn't seem like a reasonable approach. And what I realized at that time, even though I was happy about the functionality that ASEF has to offer and what kind of things it could solve, I still saw a limitation through a physical barrier where you have to connect the device in order to run a test on the machine. And I wanted to unplug ASEF by overcoming that physical barrier. And in order to do so, I came up with my very first Android app, which I called it Night Phoenix. With the help of that, ASEF is now unplugged. In a sense that all you have to do is user can just install this application, and it will extract all these application install on this on your devices. It will send it to the ASEF on the machine which is running the ASEF, and all the tests will be performed. So how Night Phoenix and ASEF will work together. So you have installed this application on your device. It will go ahead and iterate all these packages and try to find out where these APK files are located on the device. Just like the extractor module of an ASEF, except this time we are doing it locally on the device itself using the package manager library. It will create a zip file of this and store it on an SD card, and on the other side, ASEF will be listening on a predefined port to receive this zip file. And once it receives it, it will unzip it, and it will create a list of array where all these APK files will be stored. And as I mentioned, that once you figure out a way to get to this point of a normalization mode, rest of the functionality of ASEF will always remain safe. So that's the beauty of the design. And with the help of Night Phoenix, now ASEF is unplugged. That all you have to do is just click one application, and your tests are being run on the ASEF server. Why do I keep calling it Night Phoenix? That's a good question. So when I imagine this application to work with the ASEF, I thought of why even make user to go through that hassle of clicking that application every time they want to run a scan. So you can actually integrate the alarm manager library with this, which will allow you to schedule all your scans. So let's just say your user activity is at the least at the midnight. So you can schedule your scans at nighttime, and it will send all these files to ASEF server, and ASEF will run all the tests and will let you know if anything is wrong. So again, after working on Night Phoenix, I was a little bit happy that I was able to unplug the ASEF. But at one point, it really struck me that who watches the Watchman? Because I started talking about evaluating the security of the Android applications and doing all the behavioral analysis and running it through ASEF and such. But in order to overcome the limitation of a physical barrier of ASEF, we ended up introducing our own app. So I was more interested in knowing, let's just find out how secure is my own app. So what I did is I just took my Night Phoenix application and I ran it through ASEF. At that time, I didn't find anything wrong, but I started digging much more into the functionality aspect of it. What I realized is the way I'm achieving the function of Night Phoenix is by using two permissions. One is the internet permission in order to send the zip file, and to store that zip file on the SD card, I'm using the write external storage permission. And while I was going through this code, I realized one interesting thing where there are ways you can actually bypass very easily the external storage permission, where you can send all these applications one by one rather than creating a zip file and sending it at one shot. And this is something that you can play around or search on the internet how to find a way to bypass the internet permission. And once you get to that point, imagine what do you have. You have an Android application, you have a piece of code which sends all your installed application to somewhere with or without your permission. And if you can get to this point, and you might not want to call it a Night Phoenix, and if you may, please call it the Dark Phoenix. It seems like an end of a story here, but is it? Actually, it is just the beginning. I'm more excited about also talking about the next generation of ASEF, in a sense that through thinking about the next generation of ASEF, I have seen the future of automation in the field of Android security, where the functionality of this framework can be increased by adding more scalability to this framework. I'm currently developing the load balancer module, which will allow to run this test on large number of virtual devices or physical devices. The automated and custom signature generation can be easily achieved by creating all the feeds from various security bulletins, and we can actually create a real-time signature updates and such, which will make user secure at any given time. Again, there are times when I think about like having go through all these updates and updating my every single application. If these updates are distinguished in a sense that if I know that, hey, there are some of the updates which are which are the security fixes, I might be more focused on installing them rather than worrying about some UI features being introduced in the fixes. So these are the areas where I'm focusing on for further improvements and such. There is a lot more efforts need to be done in correlating all this data, creating all these results and statistics through UI, so it has better insight into what it's collecting to any user. And again, this whole framework can be sitting in the cloud, available for anybody to run a test. It seems a bit ambitious in a sense that it will require a little bit of financial investment in infrastructure and such. But to easily achieve this, you can create a central repository somewhere on the internet where all the results are stored. So maybe the functionality might not be available for you right away, but you can just query all the results and see if you are happy with it. If not, then you'll always have the framework on which you can run a test. And there might be like some offline crawlers which will be looking for applications and will feed it to the ASEF framework, and it will collect all the data offline, and it will have it ready way before you will actually scan your application. So it might even have the results of the application way before you have even given it to it. So these are the type of areas where I'm trying to improve upon. So what's today's conclusion? That ASEF is an awesome framework and everybody should use it. Well, not entirely. Today I told you the story of ASEF and what it stands for. Well, that's just the full form of it, but I'm talking more about the meaning behind it, which actually comes from the story that ASEF has to tell. When I was working on ASEF, what I realized is there is so much out there in the field of Android security to absorb, process, understand, and interpret. And the biggest question at the end of the day was how do I make sense of all these individual problems in much more comprehensive way and address them much more collectively on a larger scale. And that's exactly where ASEF comes in, where I'm trying to take things to the next level and provide a one-stop solution for almost all of our security needs. And when we get to that point, this framework will still be called ASEF, but it will be Android Security Evolution Framework. And I'm sure we'll definitely get to that point. But by the time we get there, feel free to use ASEF. Here is the link where you can get the code. It's going open source today. Here is the blog where all the details are there about the design and all the stats and how ASEF methodology and all. So there is a white paper also present inside this short blog which you can go through. It has more finer details about ASEF. And you can follow me on Twitter or you can reach me at this email ID if you have more questions. Thank you, everyone.